Okay, so from iFlyRC.com, here we have the 4-in-1 BLHeli ESC. It's a iPeak A EFM 30A ESC. This one, the specs say is D-Shot compatible. It's 30 amps, and again it's a 4-in-1 ESC. Alright, so let's see what this weighs. 10.7 bare, and these wires probably add a couple of grams. So 13.2 with the wires, but these are pretty long. Usually I'll cut them to length and then just solder direct. I don't use those connectors. So not bad. This probably weighs less than having all 4 separate ESCs. So not a lot of difference. Pretty clean PCV. Just from at first glance, you can see it's all the solder is pretty good, pretty clean. The components are pretty good quality, I think. It comes with this one page, which is not really instructions, but it's a diagram of the whole layout. So I was looking at it and then noticed that it's got a current sensor and a battery sensor output. So it's actually one of the things I noticed when I opened the package is that it does have, it came with this shunt resistor here on the battery lead. So usually that's a current sensor. Usually most current sensors have that. So I thought it would have that. So anyway, that's the it does have current sensing, so that's pretty cool. You can hook that up to minimal SD and keep track of your amps. It comes with these pigtails, these connectors, and the wire is silicone wire, so that's pretty good. It's flexible wire. Signal wire. The signal wires for the ESCs also, they're nice silicone wire. So the layout of the ESCs is supposed to be, okay, this is motor 1, motor 2, motor 3, and motor 4. So it would go like that. So you end up with like that, and your motor leads go here to the motors, to the arms. So this makes for a fairly clean build. And one of the advantages of having these ESCs inboard as opposed to on the arms is that it keeps them away from prop strikes, especially with these unbreakable props or kind of flexible props that don't shatter. What ends up happening is that you pin the props on a crash, and they keep spinning because you didn't have time to disarm, and you strike the ESC with the props and you knock off components. That's happened to me actually. Knocked off some resistors and capacitors. So then you have to source those and try and solder them and to get ESC working. So that's one of the advantages. One of the disadvantages could be if you don't, reduce space, if you don't have space in your center frame, or heat management. Though I haven't heard of that happening, because once you're moving, you have a lot of air moving through, so cooling shouldn't be an issue. Especially if you have like really good components like this one has. This one uses, I believe is IR, which stands for, I forget if that's International Rectifier, the name of the company that makes these FETs, which are very, very good FETs. So that's pretty good to see that they chose to use these FETs. Same brand that were originally used in the Rotor Geeks RG20s, which are known for being quite robust. So these should be able to handle current really well. This is the data sheet for the International Rectifier FH5301 Mosfet that's used on the IPCA 30 amp ESC. I just wanted to show you a few of the specs on this FET, just to show you that it's pretty good that they chose to use these FETs, as they are one of the most robust FETs. So that should make these ESC pretty robust. So it'll handle pretty much, it should handle pretty much any motor, all the way to 6S application. If we can make a little bit of sense on these specs, we can see that the drain to source voltage maximum is 30 amps, so that's well above the 6S specified capability, which is 25.4, I believe it is. So that's well above that, so that's pretty good. The continuous drain current, that's rated at about 100 amps. Of course, that's at all the way to 100 centigrade for the bottom case temperature, bottom case of the package of the FET itself. So once it reaches 100 centigrade, actually a little bit more than that, then there's a little bit of derating on the capacity of drain current. That's shown here on this graph. As you can see, it's 100 amps, pretty stable, all the way to about 110, 115 centigrade. And then there's that's when the derating starts, right about 130 or so centigrade. Then it becomes steeper. So it's not until you reach about 140 or so, 140 centigrade, that the derating goes to about 30 amps or so, about 100 and let's see, 125. So this would be about 130, 140 or so. Anyway, that just to show you that these FETs they chose to use are should be pretty capable, and should be able to handle pretty much any motor and prop combination that you may choose. And it's good that they chose these FETs, because these packaging is going to be in the center of the frame, and it's not going to get the same type of cooling that you would get on the arms. There's still gonna be some cooling, you know, because there's a lot of air moving through. The frame is open, so that probably doesn't mean, or doesn't mean much, or doesn't really affect it once the quads gets moving. But you know, that's it's good to see such a beefy FET being used here. Anyway, I thought I'd show you this datasheet. It's kind of interesting. Maybe some of you guys know more about all these specs. Just I can just barely make sense of all the charts and specs here. The MCU is BB2, so that's one of the fastest ones for BL-LES. So should be able to handle pretty much any high kV motor. And oh yeah, and this is 6S capable, so that's another plus. You know, if you want to run 5S with 2300 kV motors, that'll be fine. I've seen somebody on the RC groups. He's been flying 2600 kV motors on 5S, so I was quite amazed that he was able to run 5S on those high kV motors using BL-LES ESCs. I think that was on the yeah, on the Brother Hobby thread. He's using a T1, I believe it's a T1 2205 2600, or maybe a T2 2600 kV motor, 2206 I think. Anyway, so that's 6X compatible. They do recommend using a voltage regulator to power, you know, your other electronics. So don't, you know, they make it a point to tell you that, you know, not to hook up any of the electronics direct to any of these outputs. So you gotta keep that separate. So that's not a big issue. You just run a separate voltage regulator. It takes a little bit more work. If you'll need to have if you need 5 volts for your FC and 12 volts for your VTX and your camera if you have to. So it would be 2 VEX. So I'll be using this one for the iFlyRC frame, the IX5 that they also sent. So just to show you how it goes, it would go right there, like so. So it's pretty much like the size of the FC basically. It doesn't take that much more space, and it's not that thick, so it should be it's just the connectors actually what makes it. The thickest part is this connector, so that's pretty good. It won't add that much height to the stack, and the motor wires go they'll route through there like so. So that'll make for a clean build. So next I'll hook that up. I'll have to solder a battery lead here and power it and connect it through an FC so that I can hook it up to BL-Heli Suite, so we can see with the settings and see what firmware these came with. It's probably It's supposed to have the latest Be Highly firmware, but you know, always check. Anyway, you need to connect it once you have everything together, so you can set the motor rotation. So that's gonna be on the next